All right, we're going to continue on with the second half of the review for our final. State the quadrant in which this lies. This is when cotangent is positive and secant is positive. Remember that is also the same as tangent and cosine. Tangent is positive and cotangent in quadrants 1 and 3 because positive divided by a positive or negative divided by a negative. And cosecant or cosine and secant, those are your x values. Those are positive to the right. So here and here. So what quadrant is that in? Quadrant 1. And just a quick reminder on how they're labeled. We will skip number 22. Determine the period and the amplitude. Remember, amplitude is A and it's always positive. So we can eliminate C and D. The period, remember you have to factor out the B. So I have to get X by itself. So I have to take out the fifth. This is now B. So period equals 2 pi over B. And when you cross multiply or 2 pi, this gives us 1/5 times P equals 2 pi. Multiply both sides by 5, and that's 10 pi. So the answer is B. Find the relationship between the cosine and cosine 3 of x minus 13. Well, this is your B and your D. So this is going to shift down 13 units. So down 13 units, I can cross that one out. So it's between these two. This is your B, so your period, it has to do with your period. 3 times the period. The period is 3 times, so A. This is having to do with amplitude, and that is not your amplitude. So the good thing about multiple choice is you can also use your process of elimination. For the function, find A and D. Well, D is your midline. So if we can see where our midline drops, it looks like our midline is at -1, and the amplitude is 2 this way and 2 this way. So A is 2, D is -1. So B is our answer. Evaluate the arc cosine. Remember, this is the same as saying the inverse cosine. Arc cosine and inverse cosine mean the same thing. So when is cosine, remember that's your x value, square root 3 over 2. Well, x is square root 3 over 2 right here at 30 degrees, and it is also right here at 11 pi over 6. However, when we talked about inverse cosine, remember those are the values only from 0 pi to pi, so the only option we can pick is 30 degrees or pi over 6. Just a quick reminder, remember inverse sine and inverse tangent are from half a pi to -half a pi. Using your calculator to evaluate the arc tangent, remember that is just the same as saying inverse tangent, okay? So the inverse tangent of 0.68. Now, do you see a degree symbol here? I don't, but my mode must be in degrees because none of these match. So make sure you change your mode to radians, and then you can do it again, and I get it rounded to D. Inverse functions, remember when we have sine and arc sine, these are inverses, just like multiplication and division, or adding and subtracting, and so basically all these do is cancel each other out, and our answer is E. Right here, find the exact value of the tangent when the inverse tangent is 5/13. So the first thing I'm going to do with my inverse sine, is 5/13. This is so this is opposite over hypotenuse. a squared plus b squared equals c squared. And 169 take away 25 is 144, or the square root is 12. Now I can find the tangent. The tangent is opposite over adjacent, 5 over 12, or letter B. An observer is 340 feet from a hot air balloon before it takes off. Determine the angle of elevation when the balloon reaches 200 feet. We have opposite and we have adjacent. So SOHCAHTOA, the tangent of theta equals opposite over adjacent. And remember, when we're trying to find the angle, we use the inverse tangent. Or if we're trying to get rid of tangent, we would use the inverse tangent to both sides. And so when I take the inverse tangent of 200 divided by 340, I get 30.5 degrees. All right, number 31. Again, you can go ahead and read through this one. I'm not sure. I'm just double checking to see if we even need to do this one. Yep, we do. So we've got, let's see, the height of 12. The diameter is 38 feet, so that means the radius is cut in half, or 19. It says find theta, so again, tangent of theta equals opposite over adjacent, and we're using the inverse tangent. And when we plug that into our calculator, we get 32 degrees. Which of the following is equivalent? We need to use our identities. Okay, cotangent is the same as cosine over sine, minus 1 over 1 minus the tangent, which is the same as sine over cosine. In order to subtract, we need like terms. So this would be the same as sine over sine. So this gives me the cosine of theta minus sine of theta over the sine of theta, divided by, and this gives me cosine over cosine. So the cosine of theta minus sine of theta over the cosine of theta. Now, again, I like to write these out kind of the old-fashioned way. So we have the cosine of theta minus sine of theta divided by the sine of theta, divided by all of this. And then remember, when you're dividing by fractions, it's the same as multiplying by the reciprocal. So now what happens with both the top and the bottom of these two fractions is they cancel out. And now I'm left with cosine over sine, and we know that cosine over sine is the same as cotangent. So that was a lot to do for that one problem, but using your identities and swapping everything out. Okay, the nice thing about 33 is now I've got a 1, but I've got something squared. Okay, so we know that we can replace things if we need to with the squares. Now, because of addition, I can also split this up into 1 over sine theta squared plus cosine of theta squared over sine of theta squared plus 1. We know that this is the same as cotangent. So now I have 1 plus sine squared of x equals the cotangent squared of x plus 1. I know that this is the same as cosecant. And I know that 1 over the sine is also the same as cosecant. So what do I have? 1, 2 cosecant squared of x's. Number 34, cotangent, again, is the same as cosine over sine, times secant, which is the same as 1 over cosine, and these cancel out, and I'm left with 1 over sine, which is the same as cosecant. Now it says which is not equivalent, so make sure you're reading the directions. So we did prove this to be true. I also proved this to be true. And based off of a process of elimination, if it's cosecant, there's no way it can be secant, because those are not even close to reciprocals of each other. So our answer is D. Which of the following is a solution? Remember, you just solve it. Pretend the sign isn't there for a second and just solve this equation. So we add 1 to both sides and divide both sides by 2. And now throw the sign back in there. When is sine equal to 1/2? So on my unit circle, sine is my y value. It's 1/2 at pi over 6. And it's also 1/2 at 5 pi over 6. So my answer is D. Same thing with this one. If you want to make it simpler, take out the cosine for a second and solve this equation. X squared plus x equals 0. Okay? Look for GCF. That's x. And now we have the zero product property. So when is cosine of x equal to 0, and when is the cosine of x plus 1 equal to 0? Well, cosine equals 0 at, that is, remember, your x value at 90 degrees or pi over 2, and also at 3 pi over 2. When does cosine of x equal -1? That happens at pi. These are across from each other on the unit circle. So this would be at pi over 2 plus pi n, and this happens every 2 pi n. So now when we're looking for that answer, it is B. All right. Now I would add these two and give them a try on your own. Okay. 36, the answer is 5 pi over 4 and 7 pi over 4. And for 37, it is pi over 3 and 5 pi over 3. So give those a try. Again, remember, if you need to, go ahead and just solve this equation first and then throw the sign back in. Go ahead and throw this equation in first and then throw the secant. But remember, secant is the same as cosine inverse. So you're actually finding when cosine is half a pi. 39, again, find all the solutions. This time, we need to have everything with like terms. Cosecant and cotangent are not the same. However, I do know that cosecant is the same as 1 plus the cotangent of x squared. Now I need to get everything over to one side, or one side equal to 0. When I subtract 1 and subtract the cotangent of x, I'm left with cotangent squared of x minus cotangent of x equals 0. Again, you can factor out, or if you want to ignore the cotangent for a second, factor out the x, throw cotangent back in. When is cotangent of x equal to 0? And when is cotangent of x minus 1 equal to 0? Add 1 to both sides. When is cotangent equal to 1? At 1/4 of a pi and 5 pi over 4. When does it equal 0? That's when it's 0 over 1 and 0 over -1. Remember, cotangent is your x over y value. So that's at half a pi and 3 pi over 2. And we need all 4 answers, which is letter D. Use your graphing calculator to plug this in. Look for where it crosses the x-axis, and your answer is E. Number 41, we are looking for, again, use your graphing calculator, and this happens at B. 42, if you need to, go ahead and convert these into decimal times. So 9 seconds and 27 seconds. If you need, this is 9 and 45, 9.5.